Hello, my name is Daniel Shuttleworth, and welcome to my talk. My topic is the fascinating physics of Outer Wilds. Outer Wilds is a game about exploration and curiosity. In this game, you're given free reign of the solar system and tasked with unraveling the mysteries that lay spread throughout. It is a non-linear game and everyone experiences it differently. But I'm not going to talk about the story. To tell you anything more about the game would be to ruin the experience for you. So all I can do is preface that this game is a one-of-a-kind experience, and I wholeheartedly recommend you play it. What I'm going to talk about is the physics simulation aspect of the game. The game started as a master's thesis project by Alex Beecham at the University of Southern California. The aim of this project was to break new game design grounds by pulling several disparate ideas from various student prototypes. After winning the Seamus McNally Grand Prize and the Award for Excellence in Design at the Independence Game Festival in 2015, it was developed by Mobius Digital from a technical project into a full game with an engrossing story, beautiful visuals, and a great soundtrack. The previous image was an image of it as a project, a student project, and this image is the full game. So you can see the graphics have improved quite drastically. One of the core philosophies behind the Outer Wilds is that because the game is about discovery and exploration, none of the systems present in the game should be faked. Everything that the player observes must be the result of an actual simulated system, and instead of the game world being static, things must be constantly changing throughout the simulation. The best example of this is the gravity in the game. Every single object in the entire game exerts a gravitational pull on every other object in the game. This means that none of the planets are following a predefined path. They're all actually being physically simulated. So all of these planets, if you left the simulation running long enough, they would actually change their orbits and fly off into different parts of the solar system. So here's a few cool examples of what this physics system allows to happen. This clip is of a science experiment present in the museum, the home planet. The image on the top right is from a camera attached to the roof of the building to allow us to see the moon as it passes by. So if you watch the balls on the table, which is a completely flat table, you can see that they start to move. They're actually moving because of the moon's gravitational pull. This just emphasizes how it's actually every single object in the game that are affected by all gravity effects. So that's similar to how tides work on Earth. The moon pulls the water to the one side. So here's another clip of me jumping on the moon. I'm not boosting along, I'm actually in orbit around the moon. I'm just making minor adjustments. So you can have quite a lot of fun in the game. As you can see, the astronomical bodies are quite exaggeratedly small. You can see the curvature of them, but it's just for the sandbox playground type of thing. Gravity also works linearly rather than by the inverse square law. So there's a much very different effect that it has than in real life. Here's another clip where I jump from one planet to another planet. Because they're binary planets, the gravitational pull of the other planet allows me to pull this maneuver off with just my jetpack. Quite fun. You can see how the camera changes orientation when I get close enough to the new planet, just to make my life a bit easier. Finally, the spaceship. So the spaceship that you travel around the solar system with is simulated with Newtonian flight mechanics, which means that your thrusters exert a constant force which modifies the ship's velocity at a constant rate, meaning you can gain unlimited speed. This can result in unintentional side effects like slamming into a planet at multiple kilometers per second. You're also subject to the gravitational forces of all the planets hurtling around the solar system. This can lead to some intense gameplay like this. You can't hear any sound from the video, but you'll just have to imagine the Interstellar soundtrack playing in the background as this person tries to get back to their ship while in orbit around the sun. Not a situation you want to find yourself in. But with some expertise, you can see they managed to pull it off almost perfectly. And now another clip. This person is sucked onto the other of the binary planets. and themselves and their ship are pulled into orbit around the other planet because of the force. And they fall between the big canyon in this planet, if you can call it that, and another high intensity struggle to not die. Again, congratulations for this person's skill. So I wanted to do a live demo for this, but live demos are not a good idea. And that would involve me installing a game on my work laptop, which is probably a worse idea. So I have a video instead. I'm descending down this lift on the home planet, which goes deep into the belly of the planet. This is called the 0G cave. So I'm going to put the spacesuit on, which has the thrusters on it. And you'll notice the little circle thing on the bottom left that'll indicate the current forces I'm applying with the jetpack. There's the cave. So inside this cave, there's zero gravity, and that is because the mass of the planet is exerting a force from all sides. So this could actually happen in real life. If you go to the center of a planet, if you weren't dead from the heat, then it would attract you equally from all sides, and you could actually have a zero gravity experience inside a planet. So part of the demonstration, I'm going to try to repair some stuff of the satellite. It might look easy from what I'm doing, but it's actually quite difficult to control yourself with no friction and three-dimensional movement. You can look at all the erratic movements I'm making with the thrusters. And some fun facts about this game. Due to the potential floating point errors resulting from being too far away from the origin of the world in Unity, the game engine that this is made in, the center of the world is actually at the player, which means that whenever you move or jump, the force that you think you're applying is actually being applied on every single other object in the universe. So if you jump, the whole universe is moving down briefly, which is quite interesting. And here's a bonus video. In this video, I use the assistance of a geyser to make it onto the moon. The geyser has a pool of water at the bottom with heated vents. So I'm shot into space by the geyser. And now I have to try to make it to the moon without being flung off into space and never seeing my family again. Obviously, it's quite a risky maneuver, but it's quite fun. Also limited oxygen, which makes things even more fun. And if the moon hadn't been in the right spot there, I probably would have missed it. But as you can see, I make it back to the moon, to my ship, in one piece. There we go. Now, if you saw anything in this game that looks interesting, or you wonder what's that, or what's the story behind that, then you're exactly on the right track. That's exactly what the game was designed for, the exploration of space motivated by your own curiosity.